Hello, welcome back to the Physics Tutor. We're going to be working some more problems with free fall motion, but this problem begins the first in a set when we're going to still be doing free fall motion, but we're going to initially start by throwing an object up, and then it's going to reach a maximum height, and then it's going to start to fall back down. Later on, we'll have rockets that'll actually accelerate an object up, and we'll get to those later. But here we do have a couple of problems where we're throwing something up, and we're trying to figure out where does it get to its maximum height, and then what happens as it comes down into the bottom here. So I'll read the problem, and it's a good problem, but one thing I want to do before we get there is you can use some of your intuition from everyday experience in these problems. The first one is, if I were to have an object like this marker, if I throw it up and it reaches some maximum height before it comes back down, there's a couple things you already know from living on Earth that you can apply into these problems. The first one is, however long it takes for this marker to reach its maximum height, the time that it takes to reach the top is exactly equal to the time it takes to fall back down to its initial position, right? So if the initial position is here, let's pretend that I throw this thing up and it takes 1.5 seconds to reach the top. Then because of symmetry, you also then know that it takes 1.5 seconds to get back down to where it started, right? So that's something you can actually use to help these problems. And then the second thing I want you to kind of keep in mind is something you already intuitively know, is that if you launch this thing up with a certain velocity, let's say we launch it up at 10 meters per second, then it's going to reach a stopping point and then it's going to accelerate back down. At the moment that this marker passes through or reaches the same place you started from, its downward velocity will match exactly what you started with throwing it up. So if you launched it up at 10 meters a second, by the time it comes back down, when it gets down to the same spot, it's going to be going down at 10 meters per second. So those two things can actually help you solve quite a bit of problems. If you just remember that the time going up must be equal to the time getting back to the same spot, and the initial velocity you throw it back at is going to reach a height, and then it's going to accelerate back from 0 at the top back down to the same velocity but going in the other direction, that can help you. So keep those two things in mind as we solve this next problem. It says we throw a rock straight up at 20 meters a second from a building that is 50 meters tall. We want to find the following things. Part A, what is the time needed for the rock to reach the maximum height? In other words, when it stops and then it starts to go back down, how long does that take to get to the top of the max height? Number two, what is the maximum height above the throwing level? Because you're standing on a building, right? So you want to know in this part B, what is the maximum height above the throwing level? In other words, from the top of the building. Part C, what is the time that it takes for the rock to return down to your level, wherever you threw it from? The next one, what is the velocity of the rock as it passes you, where you throw it from? And part E, what is the velocity and position at t is equal to 5.0 seconds? So there's a lot of stuff here. Even though it's a simple problem, you throw a rock up and you want to basically find out what's going on, we still have to draw a picture because it's going to make it a lot easier. So the very, very first thing we're going to do, other than writing our equations down that we've been using, is we're going to draw a building. And as you can probably guess, my building is not going to be a very complicated building. My building is a nice rectangle. Okay, if you want some windows here, we'll draw some windows, you know, whatever, we can do that. But essentially this building, it tells you in the problem, it says we're throwing it 20 meters a second from a building 50 meters tall. So this distance is 50 meters. That's going to be useful. And then we're going to be standing at the top of this building. We can draw ourselves right here, happy face, standing right on top. And it says we throw the rock straight up. So in reality, we're throwing it